Hi, welcome to the channel Coder's Arc, where we unravel the world of coding and architecture together. And today I'm going to be introducing you to the concept of ontology. What is ontology? What is a knowledge graph? How are the two related to each other? What is a graph RAG architecture? How you can use ontology knowledge graphs to get a consistent, precise outcome compared to the subjective, inconsistent outcomes that you get from LLMs. In the past, I've done many videos on LLMs and agents and agentic architecture. In this video, you will understand how ontology and knowledge graphs fit into that whole framework. So I will be explaining this in a two-part series. In this video, I will be focusing more on ontology and knowledge graphs, and in the next video, I will explain you with an example, a graph RAG architecture. So without further delay, let's get right into it. Now, before you understand the concept of ontology, you have to think in terms of triples. This is very, very important. What are those three triples? Subject, predicate, and object. Subject is the entity that you're talking about. Predicate is the relationship, and object is the other entity that the subject is related to using the predicate. For example, patient John has symptom severe pain, where patient John is the subject, has symptom is the predicate, and severe pain is the object. Ontology has to be thought in terms of triples. It's very important that you think of facts in terms of triples. That way you're able to build the relationships between the entities. You're able to think and apply the rules to these entities. You're able to think and apply the specific constraints to these entities. So think always in terms of triples. Now let's start to put a little bit more structure into how ontology is read and understood by a machine or a computer. There are various standards defined to represent ontology. I'm going to explain the OWL standard, which is the Web Ontology Language W3C standard. It is essentially an XML standard to define the various elements of ontology. Let's look at what the elements of an OWL file are. First, you have classes which define the various entities in your domains, like person, organization, product. These are the basic building blocks of your ontology framework and can have hierarchical relationships just like code classes through subclass declarations. Then you have object properties. These define the relationships between the instances of classes. For example, works for, which connects a person to an organization. In this case, works for is an object property of the person class. Has part, which can link the components. Essentially, you can think of these are the verbs that connect your entities. Then you have data properties. These are attributes which have literal values like strings or numbers or dates. Example, has age, usually always has a value. Has name has a string value. Created date has a date value. These attach the actual data to your instances. Then we have the individuals, which are instances. For example, the concrete examples of your classes. Example, Amazon is an instance of an organization. It's not an instance itself. It's not an entity itself. It's an instance of an organization entity. This is actual knowledge-based data. And finally, we have axioms and constraints. These are the semantic logical rules that make the web ontology language powerful. Things like min, max occurrences, the domain and range definitions. For example, which classes can use which properties, equivalence and disjointedness declarations, and property characteristics like transitive, symmetric, functional, etc. I won't go into a whole lot of details into these constraints and rules because by itself it's a big topic, it's a domain in itself, but my goal for this video is that you understand the characteristics of an OWL file. What you're looking at right now is a healthcare ontology.owl file. Essentially, as you can see, it's an XML file using the W3C OWL standards. Each entity has a unique URL attached to it. The URLs are used in HTTP format just so they can be unique. But essentially, if you look at it, there is a definition of the top level classes. For example, healthcare entity is the top main class. Then you have the person and patient, which are the subclasses of the healthcare entity class. Then you have symptoms and pain classes. Pain is a subclass of symptom class. Similarly, there are different body locations, medications and drug classes, different entities that are defined in this ontology file. Usually you want to define ontology using the expertise of subject matter experts, scientists, R&D teams, architects, customers, solution consultants, business development teams, as these people have a lot of domain knowledge. The goal for creating an ontology file is that you get the knowledge from these different people. Whatever is in their head, get into a format that is well understood by a machine. That's one of the most challenging exercises, but it's very fruitful because of the outcomes that you get are so precise and consistent. Then you have, continuing on to the object properties, you have various object properties. As you remember, these are the things, the verbs that connect entities to each other. Then you have you can keep scrolling down, you will see the data properties, which essentially provide number, date, time or string values to the specific instances of classes. And finally you have the reasoning rules. These can get as complex as you want using the regular expressions or some SML swirl rules that are defined. And then specific class restrictions, essentially like severe pain must have intensity greater than or equal to 7. This is a very specific rule for a class that is defined in this OWL file. For your domains, you can define your own rules. So essentially that's how an OWL file is constructed. And the way to construct an OWL file is you won't have the most perfect structure up front. You will have to work and evolve your OWL file over a period of time, working consistently with the various stakeholders like I had mentioned. Now I have run a tool called WebOwl. I have installed it locally and I want to show what an ontology looks like graphically. As you can see, all the entities are laid out. They are shown as circles over here. Then you can see, if you zoom in, you can see the specific relationships between the various entities. For example, analgesic is a subclass of the drug class, which is essentially a subclass of the healthcare entity class. Similarly, person is a subclass of the entity class. Then there are some object property relationships that are there between different classes. For example, the drug class requires requirement. The pain has intensity, pain intensity. As you can see, this tool is very important and very useful when you're trying to lay out the ontology graphically, just so you can visually understand how the different entities are laid out and how they are connected to each other and what kind of relationships and constraints exist between these various entities. Now that you understand the structure of an OWL file and ontology, let me explain what knowledge graph is. Knowledge graph is nothing but a current snapshot of the way ontology rules are applied to a current data set. For example, I'm showing you some ontology rules of a YouTube content creator. For example, the rules are: content creators can create videos, videos must belong to exactly one channel, viewers can subscribe to channels, and subscribers can watch multiple videos. Where knowledge graph would be a snapshot, would specify those same ontology rules and create a knowledge graph saying Ankit, who is a creator, creates a AWS Bedrock Agents tutorial. AWS Bedrock Agents tutorial belongs to Coders Arc channel. Coders Arc channel has subscriber count of 10,247, which I'm nowhere near that. And user X watches AWS Bedrock Agents tutorial. So as you can see, the knowledge graph is a snapshot of the ontology rules applied to it. So I want to visually show you how the previous example of medical healthcare, medications, pains, symptoms, and patients shows as a knowledge graph. So going back to the previous example of the patient healthcare data, This is a knowledge graph, which is a representation of the ontology rules applied to the specific document. So, for example, in my case, there is a patient John who is an healthcare entity, has severe pain. So, as you can see, it is related to severe pain, which is an entity, NSAID, which is also an entity, and oxycodone, which is also an entity. And the way it's related to the severe pain is using the predicate has symptom. The way patient John is related to NSAIDs is using the predicate is allergic to, and the way patient John as an entity is related to oxycodone is takes medication. So similarly, you can click on other entities and you can explore how they are related to the different entities. Again, this knowledge graph is created using the ontology rules that you must have defined for your specific domain in the OWL file. I will explain all of that, how that is created in the next video, but for now you just need to understand the concept. Finally, I want to emphasize that a knowledge graph without an ontology is like a dictionary without definitions. Essentially, all of the information is dumb data without the rules, structure, correlation, constraints that are defined by an ontology framework. Think of it as an example. If I have a patient John who takes aspirin and a patient John who's also allergic to non-steroidal anti-inflammatory drugs, without the ontology, you would just see these two things as facts. But because of ontology, you will realize that aspirin is a non-steroidal anti-inflammatory drug, so patient John is actually at the risk of having an allergic reaction. Without knowledge graphs and without ontology, these facts would not surface. That's why it's very, very important to first define the ontology and then construct the knowledge graph from the ontology, and then use that knowledge graph to pass as the context to the LLM to derive facts for your specific outcomes. Now I'm very briefly touching on this. In the next video, I will introduce you to the concept of graph RAG architecture and how a knowledge graph once created can be explored using Neo4j, and how you can ask very specific questions that are not visible to the naked eye to the knowledge graph and get some real good insights into your data. So hopefully you found the content in this video useful, and if you did, please hit the subscribe and like button, and goodbye for now.